Hello everyone. In this video, I will be presenting a very interesting use of data mining in detecting influenza epidemics by using search engine query data. So, epidemics like seasonal influenza are a very big health concern since they spread out very rapidly, and in certain seasons they have a very high cause of many respiratory diseases and also deaths. The early detection of diseases is very crucial in order to stop the spread of it, and it can affect lots of people in a very short period of time. So this needs to be stopped. The goal is to estimate the current level and spread of influenza and give the analysis for the entire week so that it can be useful to take actions on early stages. This work is originally published in the journal Nature, and I mentioned some references for it. So let's see how this goal can be achieved. Well, for the data, we use historical Google search engine queries, specifically between year 2003 and 8. And those queries particularly give us the topics of the query and uh, through which geographic region has the query originated. So we have the IP addresses, so we can figure out which area did that query fired. And we convert this data into a time series of weekly counts. So this way we have an aggregated data of weekly counts of the queries belonging to a particular topic. And we select 50 million of the most common search queries in a particular time frame with respect to a particular geographic region. Now, there are two challenges in front of us for this. And the first challenge is about query selection. Since a lot of queries depend on the subject matter, and as we have seen that the query keywords are very important in knowing the intention of the user. It is important to weigh the queries according to its frequency and its topic. So we need to weigh the queries that can accurately model the influenza problem. And the second challenge is how many of those queries should we consider? Since there are lots of queries and considering a subset of, let us say, top 100 or top 40 ranking queries would substantially change the results since it may contain many outliers. Second part is the publicly available data set provided by CDC, the Center of Disease Control, which provides the surveillance data used in previous years. So we can use this as our training data set to model the correlation between the queries and the US CDC data. Well, let us think why this should work. For some assumptions, uh, lots of people in America search online for information related to some disease or a treatment. And that is why we believe that the web search queries is a potential source of information for health related data. For the solution to this problem, this research work has fitted a linear model to estimate the probability of a random physician visit in a particular region, that is, influenza-like illness-related cause, or in short, ILI-related cause. In this model, we try to predict the physician visit related ILI given the probability that a random search query submitted is ILI related. So as you can see, we have used a logit function which takes the logouts of an ILI physician visit and the logouts of the query. And there are some parameters that we learn by running this model on the data set. But still, the first challenge that we saw earlier was that how to choose the candidate queries, the queries that can most accurately identify and help us build this model. For this, we first apply our model and see how it would fit on the CDC ILI data, and uh, and that corresponds to a particular region by using only single query as an explanatory variable or an independent variable Q. We score the queries with positive rewards that exhibit regional variations that are similar to the CDC dataset. So, and we repeat this process on the entire set of queries that we have. In this manner, we can come up with the most accurate search queries or search topics that can help us in building this model. Now, as you can see in this graph, we have a black line that indicates our model's predictions of ILI or influenza related percentages, and we have a red line which indicates the data provided by CDC. Notice that CDC data is not available for each and every month of the year. It is only available for the specific influenza seasons, but that should not be a big problem. And as we can see that our black line, which is essentially the model's predictions, are highly correlated with the results of the CDC data. Another question is that how many queries should we include in order to get the best results? If we plot the graph of mean correlation versus the number of queries, then we see that there are 45 queries giving highest correlation between the data we have predicted and the data available in the CDC. You can see a steep descent in after the point 80, and that's probably because some irrelevant queries are also accounted after point 80, like Oscar awards. Now, we look at the results. We use fourfold cross-validation, and on 42 points on a particular region for the time frame 2007 to 8, which was not earlier considered in our model training, and we obtain a mean correlation of 0.97 with it, which is highly accurate. When we really put this model on work, the results were compared with the state of Utah, which provided the data later on, and we found that our model is doing a really good job on predicting the influenza trends. And as you can see, there are some weak gaps. So our model is way ahead of predicting the spread of the influenza by calculating the ILI percentages. And this is how the red line here indicates the data that is being provided by the state of Utah. And as you can see, it is quite following our own predicted values of ILI percentage. So this is one of the many interesting use cases of data mining in real world. I hope you enjoyed it. Thank you for watching.